Humanity has always looked up at the night sky. We have always wondered, what is out there? Where did we come from? For millennia, our view was limited to what our eyes could see, tiny pinpricks of light in an overwhelming darkness. But we are a curious species. We built tools to see further. We built telescopes that gathered more light, revealing misty nebulae, revealing distant galaxies. Each new instrument was like opening a new window onto the cosmos. Now we have opened the grandest window of all. It is called the James Webb Space Telescope. It is a magnificent golden eye, floating 1,000,000 miles from Earth, staring into the deepest, darkest corners of space and time. This is not just another telescope, it is a time machine. Before Webb, our understanding of the early universe built on a solid foundation of theory and observation. We have a very successful model called the Big Bang. It tells us that about 13.8 billion years ago, the universe began in an incredibly hot, dense state, expanding and cooling ever since. For the first few 100,000 years, it was a foggy, opaque soup, particles and energy. Then, as it cooled, atoms formed, the universe became transparent. This was the beginning of the cosmic dark ages, a time of quiet, a time of darkness, before the first stars had been born to illuminate the cosmos. Scientists believed the first stars would have been giants, monsters, hundreds of times more massive than our sun, made of almost pure hydrogen, helium, simple elements forged in the Big Bang. These stars would have lived fast and died young, exploding as brilliant supernovae. In their fiery deaths, they created heavier elements, carbon, oxygen, iron, necessary for planets and for us. These elements would seed the next generation of stars. It was a slow, gradual process of building up complexity over hundreds of millions of years. Following this logic, the first galaxies should have been small, messy. The first deep field images from Webb came back to Earth. They were breathtaking. Thousands of points of light, each one a galaxy, filled the screen. Some were nearby, bright and clear, but others were incredibly distant, their light ancient and faint. As astronomers began to analyze these distant specks, a mix of confusion and excitement. The data was not matching the predictions, not even close. The universe's baby pictures were not what we expected at all. Among the faint red dots of the early universe, Webb found something startling. It found galaxies that were far too large, they were far too bright, and they were far too well structured. These were not the small, messy, infant galaxies our models predicted. They were cosmic giants, already blazing with the light of billions of stars. They had the mass and structure of galaxies that should have taken billions of years to form. Yet here they were, shining brightly in an era when the universe was only 500 to 700 million years old. That is incredibly young in cosmic terms, less than 5% of its current age. Imagine looking at a photograph of what you thought was a newborn baby and discovering it was already a fully grown adult. This discovery doesn't just add a new chapter to our story of the universe, it actually forces us to go back and reread the very first pages. The standard model of cosmology, known as Lambda CDM, is our cosmic rulebook. It describes a universe filled with cold, dark matter, CDM, and dark energy, lambda. This model has been incredibly successful at explaining the cosmic microwave background and the large-scale structure of galaxies we see today. The model is built on gradual hierarchical formation, diagram, standard model, slow hierarchical mergers versus rapid direct collapse. In the standard picture, gravity works slowly. After the Big Bang, dark matter began to clump together into invisible scaffolds, halos. Normal matter was then drawn into those halos by gravity. The impossible galaxies found by Webb smash that speed limit. They are too massive, they are too early. To make so many stars so fast would require efficiency our models call impossible. There just wasn't time for slow collapse and merging to build these structures. It's as if the universe skipped several steps in its instruction manual. Either our understanding of gravity and dark matter is incomplete, or there is an unknown mechanism for galaxy formation. The implications are staggering. To truly grasp the scale of this shock, let's use an analogy from human history. Imagine you are an archaeologist digging in a remote part of the world. 10,000 years ago, humans lived in small, scattered hunter-gatherer tribes. They used simple stone tools. They lived in temporary shelters, caves, huts made of branches. You expect to find flint arrowheads. Instead, your shovel hits something hard. It's not a rock, it's reinforced steel. You keep digging and unearth the foundation of a modern 100-story skyscraper. The building has plumbing, electrical wiring, remnants of high-speed elevators. This discovery would be impossible. It would shatter your understanding of history. It's not just an anomaly, it's a contradiction. This is the shock Webb's discovery of massive early galaxies has sent through astronomy. The small, messy proto-galaxies we expected are the Stone Age huts of the cosmos. The massive, well-structured galaxies Webb found are the cosmic skyscrapers. They appear fully formed at a time when the universe should have only had the building blocks, simple tools to create primitive structures. They are anachronisms. This discovery ripples outward, touching upon some of the deepest questions we have about the cosmos, including the potential for life. The story of our own existence is tied to the story of our galaxy, the Milky Way. Our sun is a third-generation star. The heavy elements that make up our planet, our bodies, the iron in our blood, the calcium in our bones, were forged in the hearts of earlier stars that lived and died long ago. This cosmic recycling was thought to be slow. It would take billions of years for a galaxy to be enriched enough to form rocky planets like Earth. But if massive, mature galaxies can form so much earlier than we thought, it could change the timeline for life. A galaxy that grows big and fast is rapidly producing and distributing heavy elements. That means ingredients for rocky planets, and perhaps life, could be available much sooner. This puzzle forces us to confront the great unknowns of cosmology. Dark matter, dark energy. They make up about 95% of the universe, yet remain mysterious. What if dark matter isn't so cold? What if dark energy changed over time? These early, massive galaxies might be the first clue our assumptions are wrong. They could mean dark matter allows much faster collapse in the early universe, or dark energy's early properties could have favored quicker galaxy growth. These are profound possibilities. These galaxies aren't just objects, they are probes. They test the limits of our knowledge about reality. They remind us the visible universe is the tip of a vast, invisible cosmic iceberg, and this tip behaves in a way that suggests the hidden bulk is far stranger than we ever imagined. Every great leap in science begins not with an answer, but with a question that challenges our assumptions. Galileo looked at Jupiter and saw moons orbiting it, challenging the idea that everything must orbit the Earth. Edwin Hubble looked at distant nebulae and saw they were rushing away from us, challenging the idea of a static universe. We are now living through another one of those moments. The James Webb Space Telescope has looked into the cosmic dawn and found galaxies that should not be there. It has given us not a neat confirmation of our theories, but a beautiful and profound puzzle. This is not a failure of science, it is its greatest triumph. The purpose of an instrument like Webb is not just to confirm what we already know. It is to push us into the unknown. It is to find the edges of our knowledge and show us where our maps are wrong. The discovery of these impossible galaxies is a gift. It tells us our understanding of the universe's childhood is incomplete. There are exciting new physics and new processes waiting to be discovered. It has ignited a new fire of curiosity, sending theorists back to their blackboards and observers back to the telescope to gather more data. The James Webb Space Telescope is still young. Its mission has only just begun. We are the first generation to see the cosmic dawn with such clarity. And as we continue to stare through this new window on the universe, one thing is certain. The universe has many more surprises in store for us. The journey has just begun.